Welcome back, everyone, to another session of ML Algorithms Coding. In this particular session, we will be conducting the session 6 for understanding the decision trees algorithm that we have. So before we start on with what is decision tree, I would like to show you a sample figure of how a decision tree looks like. So in this particularly, you can see here we have a decision tree which is divided into a couple of nodes, and then those nodes are further subdivided until we reach the leaf nodes. So for if I want to give you an example of a decision tree, whether for this decision tree is based on like whether someone should accept a job offer or not, and this first he's seeing like whether the salary matches his expectation. If no, he declines. If it matches, then he sees if his office is near your home, if it particularly matches, then he sees whether the office provides cab facility. And if it's yes for everything, he will accept the offer. Otherwise, he's going to decline the offer. So let's come back to understand what decision tree is. A decision tree is a machine learning algorithm used for classification and regression tasks. Generally, it's used for classification tasks, but it's very common to use decision tree for the regression task also. It consists of tree-like structures where each internal nodes represent a feature or attribute, and each branch represents a decision based on that particular feature, and each leaf node represents a predicted output. So for example, what we just saw right now is like we'll have a root node, then that would be divided into some decision trees, sub trees based on the attributes, and then finally, based on subdivision, it determines the combination of some attributes. And to train a decision tree, the algorithm uses a supervised data set. It starts with the root nodes, which includes all examples. Then it selects the feature that provides the most information gain to split the data into two subsets. It then repeats this process for each subset until it reaches a stopping criterion such as the maximum depth or the minimum number of examples in a leaf node. Once we have trained the decision tree, it can be used to predict output for new unsigned examples. And one of the very good examples that decision trees has is it's like very easy to interpret and visualize, handling both numerical and categorical data. Also, when it comes to handling this missing values, decision tree is a very good machine learning algorithm. However, it's very easy for decision trees to suffer from overfitting, and if the tree is too complex or if there's noise or outliers, it just is prone to overfitting. And to address this issue, there are many techniques such as pruning, ensemble methods, regularization. To simplify a decision tree or create an ensemble of different trees to improve generalization performance. And it's not a good practice to use decision trees on the imbalanced datasets or datasets with many irrelevant features. So one of the things is one of the heart of what we just discussed in the decision tree is how do we select the features that provide the most information gain to split the data into two subsets. Generally for this, there are a couple of ways how do we do this thing. So first is using the entropy and second thing is using the Gini. So here we will see, here I'll tell you, explain you with the help of example for calculating the Gini values. So for that, I'll use reference of here. So in this particularly where if you have entropy, the entropy is given in such a way, I won't go into the detailed mathematics of this thing. And for Gini, what we are going to discuss, it's like giving as 1 minus probability of ith, the square of probability of ith. Next. So we prefer, and when building a decision tree, we would prefer to choose the attribute with the least Gini index as the root node. For example, if you want to predict like whether market will go up or the return will be up or down or something like that, we'll see the different attributes such as past strength, open interest, trading volume. Right. For each of these data points that we have, we'll try to calculate the Gini index, Gini values. So here we will calculate Gini values for past trend and the Gini values for the open interest, past trend and open interest. So particularly if you see, like, we'll have, I think, six positive, four negatives, and similarly here we have around four highs, six, something like six negatives. So here we will calculate the probability. From probability we will calculate the Gini index. It's like one, then the second thing, and similarly we try to calculate the Gini in the other case, and then we'll take the weighted sum for the positive and the for both the negative, and this is what we got the Gini values. Similarly, we'll calculate the Gini values for open interest, and based on that, how our final output is defined. So, for example, if we have the interest equals to high and interest equals to low, these are the probabilities. If open interest equals to higher and the final return that we got is up, then in that case, probability is 2 or 4. And in case interest is higher and return is down, the probability is same. So we'll get a Gini value of zero point 0.5. Similarly, we'll get Gini value for the open interest low is 0.45. And then finally, we'll do weighted average of both the values. Similarly, we'll calculate the Gini index for trading volume, and then I'm not gonna go deeper into that. And then finally, we'll get Gini index for dividing these particular for the dividing the data set on these particular attributes that we have. And from this, we can clearly see the past trend is something that it has the minimum Gini index. So we'll be choosing that thing for dividing the first node, for dividing the root node into two subsets. And based on that, we'll then further select which one to choose based on the Gini values that we get. Right, so first we chose that thing, then we had to calculate Gini values for trading volume and open interest. So I think in this case, we'll go with the trading volume, and then finally we'll divide on the basis of open interest. So coming back to our code, now let's start to code this particular thing. So in this, we define a data class entries in which we have defined maximum that in case if it just keep on dividing, and we are not reaching anything. So we kind of put a maximum depth to keep our tree constrained to a certain length. Otherwise, tree might become too deep, and it might be prone to overfitting. So we have defined basic initializations, then we do the grow tree. We'll try to understand this method grow tree further. Okay, so particularly in Gini, what we try to find is we try to find the impure in I think underscore Gini. What we are trying to find the Gini values for a particular set of uh, arrays, right? And then the best split. I think these two are the main functions that we are going to have. In best split, what we will try to have is will I think for all the features that we have, we'll have certain thresholds defined and numbers on the left, number on the right. And then for each of the values, I think here is the size of the final labels that we have. For each of the values, we'll try to see the number on the left, number on the right, and then we'll try to calculate the Gini values for left, right, then take a weighted average to finally calculate the Gini values, and then based on that, we'll try to calculate the minimum value of Gini. If the current value of Gini is less than the earlier minimum value, we'll update the best Gini as the minimum value, and based on that, we will define the thresholds. And based on that, for each of the attribute, I think we will get a minimum Gini value. And for each of those values, particularly, we'll store everything. And then finally, when where are we using the best split? I think we will be using the best split in when we are growing. Yeah. So when we are growing, it's what we are doing. Yeah. Yeah, so particularly if you would have seen in that particular example, we are growing tree a level by level. For example, for the first level, what we will do is first level we'll try to find the Gini values. We'll try to find which particular feature gives the minimum Gini value, and then based on that we will try to go one level down. So we will try to go on the left, we'll try to go on the right, and then again repeat the same example and then finally return the values of the nodes. And once we have created the different nodes, uh, then particularly we'll see if we'll try to see where that particular the new input that we have, whether it lies on the left or the right, or if it doesn't like, we'll just keep on iterating until we get to the final leaf node of that class. And then finally, we just see if that thing is particularly leaf node or not. If it's a leaf node, we just end that end then and there only. So in leaf node, generally, if you would have worked with data structures, self dot left and self dot right, if a particular node has no childs on even on the left and even on the right, then we define that particular node as the leaf node. Now for testing this thing, I think we are just using this predictor. All I think that's it for this thing. And the most important thing to understand in this particular example are is how we are growing the tree and how we are calculating the Gini values and how on each level we are calculating the Gini values and taking the minimum values from that particular thing. So I hope I was able to clear out the decision tree algorithm and trying to help you out with the coding of decision tree algorithm. In case if you have any doubts or any feedbacks, please let me know in the comment section. And thank you very much. See you in the next session.